A single teaspoon of material from this object would weigh billions of tons on Earth. Not millions, not billions of kilograms, billions of tons. And somewhere in the universe, countless of these impossible objects are silently spinning in the dark. When a massive star reaches the end of its life, something extraordinary happens. For millions of years, the star fights a constant battle. Gravity pulls everything inward, while nuclear fusion pushes outward. As long as fusion continues, the star remains stable. But eventually, the fuel runs out. The outward pressure weakens. Gravity wins. The star collapses in a fraction of a second. The outer layers explode outward in one of the most powerful events in the universe, known as a supernova. What remains behind is something almost beyond human imagination. A neutron star. These objects are among the strangest things ever discovered. Most neutron stars are only about 20 kilometers across. That is roughly the size of a city. Yet inside that tiny sphere is more mass than our sun. Think about that. The sun contains about 99.8% of all the mass in our solar system. Now imagine squeezing that enormous amount of matter into an object no wider than a city. The result is a neutron star. The density becomes so extreme that ordinary matter can no longer exist the way it does on Earth. Inside atoms, electrons normally orbit around nuclei. But during the collapse of a massive star, the pressure becomes so intense that electrons are forced into protons. The two combine and form neutrons. The star effectively becomes a gigantic ball, made mostly of neutrons packed together as tightly as nature allows. This is where things start becoming truly difficult to imagine. A sugar cube-sized piece of neutron star material would weigh around 1 billion tons. That is roughly equivalent to the weight of a large mountain compressed into something small enough to fit in your hand. If such a piece somehow appeared on Earth, it would punch straight through the planet due to its enormous gravity and density. Fortunately, neutron star matter cannot survive outside the extreme conditions that created it. But the numbers reveal just how bizarre these objects really are. Gravity on a neutron star is terrifyingly powerful. A person weighing 70 kilograms on Earth would effectively weigh billions of kilograms near its surface. The gravitational pull is so strong that the star significantly bends the surrounding space and time. According to Einstein's theory of relativity, time itself slows down near extremely massive objects. If you could somehow observe a clock on a neutron star, it would tick more slowly compared to one far away in space. Neutron stars are also among the fastest spinning objects known. Some rotate several hundred times every second. Imagine a city-sized object containing more mass than the sun spinning faster than a kitchen blender. These rapidly rotating neutron stars are called pulsars. As they spin, powerful beams of radiation shoot from their magnetic poles. If those beams sweep across Earth, astronomers detect regular pulses of energy. The timing is so precise that some pulsars are more accurate than atomic clocks. They act like giant cosmic lighthouses scattered across the galaxy. Yet their magnetic fields may be even more astonishing. Some neutron stars possess magnetic fields trillions of times stronger than Earth's. These extreme versions are called magnetars. A magnetar's magnetic field is the strongest known sustained magnetic field in the universe. If one passed halfway between Earth and the Moon, its magnetic force could disrupt electronic devices across our planet. Fortunately, the nearest known magnetars are safely distant. Scientists continue studying them because they represent physics pushed to its absolute limits. But perhaps the most exciting discoveries happen when neutron stars collide. For decades, astronomers suspected these collisions could create some of the universe's heaviest elements. Then came a historic breakthrough. In 2017, scientists detected gravitational waves from two merging neutron stars. These waves were tiny ripples in space-time itself, first predicted by Einstein over a century earlier. Observatories around the world watched the collision. The event confirmed that neutron star mergers produce enormous quantities of precious heavy elements. Much of the gold, platinum, and other heavy materials found throughout the universe may have originated in ancient neutron star collisions. The gold in jewelry, the platinum used in technology. Even some of the atoms in your body may trace their origins back to violent cosmic explosions involving neutron stars billions of years ago. In a very real sense, pieces of these extraordinary objects are connected to our own existence. Yet many mysteries remain unsolved. Scientists still do not fully understand what exists at the very center of a neutron star. The pressures there are so extreme that matter behaves in ways impossible to reproduce on Earth. Some theories suggest that exotic forms of matter may exist deep inside. Others propose entirely new states of matter that physics has not yet fully explained. Every new observation brings clues. Every new discovery raises new questions. Neutron stars sit at the boundary between what we know and what we do not know. They are laboratories of extreme physics created by nature itself. Tiny compared to most stars, heavier than the sun, denser than anything humans can truly visualize. Objects where gravity crushes atoms, time slows down, magnetic fields become monstrous, and collisions create the ingredients for planets, technology, and even life. The universe contains many wonders, but few are as strange, powerful, and mysterious as neutron stars. And somewhere in the darkness of space, countless of them continue spinning silently, carrying secrets that science is only beginning to uncover. If humanity could safely visit a neutron star and witness its surface with our own eyes, what do you think would be the most shocking thing to see?